In this episode, we're going to look at monitoring and logging as a privacy design problem, not just a security operations task, because the same visibility that helps you protect people can also accidentally expose them. Beginners often assume that if you collect more logs, you are automatically safer, but logs can become a second copy of personal information that is widely accessible, retained too long, and shared too broadly. Monitoring is about noticing what is happening in systems so you can detect misuse, failures, and attacks, while logging is the practice of recording events and context so you can investigate and prove what happened later. The privacy challenge is that you want enough detail to detect and respond to incidents, but not so much detail that the monitoring system itself becomes a high-risk dataset about individuals and their behavior. When this balance is handled well, monitoring supports privacy by detecting access misuse quickly, confirming that controls are working, and helping contain harm. When it is handled poorly, monitoring undermines privacy by creating new exposure pathways that did not exist in the original systems. A strong foundation begins with a clear mental model of what monitoring and logging actually collect, because many beginners picture logs as harmless technical noise. Logs can capture identifiers, such as user IDs, email addresses, IP addresses, device identifiers, session tokens, and transaction references, and those fields can be personal information even when they look like system data. Logs can also capture content, such as request payloads, form fields, message text, and error traces that include pieces of user data, and content is often the most sensitive part of what gets logged accidentally. Monitoring can add another dimension by collecting metrics and traces, which can show patterns like when a person logs in, what features they use, and how often they perform certain actions, and these patterns can be sensitive even if the content is not visible. Privacy risk grows when logs are centralized, copied, and retained in large volumes, because centralized logs are attractive targets and are often accessed by many roles. The first privacy skill is to recognize that observability data is still data, and it deserves the same minimization, access control, and lifecycle discipline as any other dataset. When you hold that idea firmly, the rest of the design becomes more straightforward. The primary reason monitoring supports privacy is that privacy depends on controlling access, and monitoring is how you verify access control is actually being enforced in real life. Without monitoring, an organization might believe least privilege is working while a misconfigured role quietly provides broad access to sensitive datasets. Monitoring can reveal unusual access patterns, such as a user account downloading large numbers of records, a service identity making repeated high-volume requests, or administrative access occurring at unusual times. It can also reveal authentication anomalies, like repeated failed logins or sudden changes in login locations, which can signal account takeover that could lead to personal information exposure. For beginners, it helps to see monitoring as the smoke detector for privacy, because it does not prevent the fire by itself, but it tells you early enough to contain damage. Early detection reduces the number of records exposed, reduces how long misuse persists, and improves the organization's ability to respond accurately to affected individuals. When monitoring is designed around meaningful signals, it becomes one of the strongest privacy protections an organization can operate at scale. The risk, however, is that monitoring can drift into overcollection, where teams capture everything because it seems useful and then keep it indefinitely because it feels cheap. Overcollection is a privacy problem because it increases the amount of personal information stored outside primary systems, often without the same governance. It also increases the number of people who might access sensitive data, because logs are frequently used by developers, operations teams, security analysts, and sometimes third-party vendors. Another problem is that logs are often replicated into multiple tools, such as dashboards, alerting platforms, ticket systems, and archive stores, which multiplies exposure and complicates deletion. Beginners often believe the risk is only an attacker stealing logs, but a more common risk is internal misuse or accidental disclosure, such as sharing a log snippet that contains sensitive values in a chat or ticket. When logs contain session tokens or credentials, overcollection can create direct security failures as well as privacy failures. The discipline is to collect what you need to protect systems and people while deliberately excluding content and sensitive identifiers that are not necessary for detection and investigation. This is privacy by design applied to observability. A privacy-aware logging strategy starts with purpose, because the purpose determines what should be captured and what should not. If the purpose is to detect security incidents, you need event types, timestamps, outcomes, source context, and identity indicators that help you understand access. But you usually do not need full content of user submissions or full records of personal data. If the purpose is troubleshooting application errors, you need error codes, system state, and non-sensitive contextual details that allow engineers to reproduce and fix issues, but you rarely need to store entire request bodies or sensitive form fields. Beginners should practice the habit of asking what decision the log entry supports, because every data element should justify its place in a log. Another helpful idea is to design different logging levels, where routine logs remain minimal and deeper diagnostics are enabled only temporarily and under controlled conditions when investigating a real issue. This approach reduces everyday exposure while still allowing problem solving when it is genuinely needed. Purpose-driven logging also supports transparency and defensibility because the organization can explain why it collected specific observability data and how it is used. When the purpose is clear, the temptation to log everything becomes easier to resist. Data minimization inside logs is especially important because log pipelines often capture information automatically from requests and responses. A practical privacy approach is to design logging so sensitive fields are redacted or excluded by default, meaning the safe behavior is the standard behavior. That can include masking identifiers, omitting payload content, and avoiding the recording of authentication secrets, such as passwords and tokens. Beginners should understand that many of the worst logging mistakes are not malicious. They happen when an engineer logs a full object for convenience, and then that object contains personal information. Another common mistake is logging full URLs or headers that include session identifiers, which can accidentally expose valid access keys inside monitoring systems. Minimization also includes careful handling of error traces, because stack traces and debugging output can leak data values that were present in memory. A privacy-aware program establishes clear rules about what must never be logged and provides safe logging patterns that teams can reuse without thinking too hard. When minimization is built into logging frameworks and reviewed during development, the organization avoids creating a hidden dataset of sensitive content that persists outside primary controls. Good minimization makes logs more useful too, because cleaner logs reduce noise and focus attention on meaningful events. Retention and deletion policies are where monitoring programs often fail, because logs feel operational and teams keep them longer than necessary. From a privacy perspective, retention should be tied to purpose, such as how long logs are needed to investigate incidents, meet audit needs, and support reliability analysis. Keeping logs forever increases exposure and makes it harder to honor lifecycle commitments, especially if logs contain identifiers that can be linked to individuals. Beginners should also understand that retention needs to account for multiple copies, because logs are often archived, backed up, and exported into incident tickets or long-term storage. A disciplined program defines retention windows for different log types, such as shorter windows for high-volume application logs and longer windows for security audit logs when justified, and it enforces those windows automatically rather than relying on manual cleanup. Retention must also consider the sensitivity of log data, because more sensitive fields should drive shorter retention and stronger access boundaries. Another key point is handling legal holds and investigations, where some logs may need to be preserved temporarily, but those exceptions must be documented and time-bound so they do not become permanent retention. When retention is purposeful and enforced, the organization reduces long-term exposure while preserving the ability to defend decisions and investigate incidents. Security information and event management, SIEM, is a common concept for centralized security logging and correlation, and it is useful to understand because it shows how monitoring can both help and harm privacy, depending on design. SIEM collects events from many sources and helps detect patterns that would be hard to see in one system alone, such as coordinated credential stuffing or lateral movement attempts across multiple services. The privacy benefit is that earlier detection can reduce how much personal information is exposed during an incident. The privacy risk is that aggregation creates a powerful dataset that can reveal user behavior across systems, which can be misused if access is too broad or if retention is excessive. Beginners should think of ASIEM as a high-trust tool that requires strict governance, because its value comes from centralization, and centralization increases blast radius. A privacy-aware approach limits what fields are ingested, applies masking where possible, restricts access to the smallest set of roles necessary, and audits usage to detect misuse. It also ensures that correlation rules are designed to detect security threats rather than to profile individuals for unrelated purposes. When SIEM governance is disciplined, the tool strengthens privacy by improving detection and accountability without becoming a surveillance platform. Metrics and tracing are part of modern observability, and they come with their own privacy failure modes that beginners should recognize. Metrics are aggregated numbers like error rates and latency, and they often have low privacy risk when designed correctly, but they can become risky if they are tagged with identifiers that allow linking behavior to specific individuals. Tracing follows requests across services to understand performance and dependencies, and traces can capture headers, identifiers, and sometimes payload fragments, which can become sensitive quickly. The privacy goal is to design metrics and traces to focus on system behavior rather than personal behavior, and to keep identifiers minimal and ephemeral when they are needed. Beginners sometimes assume that because metrics are numbers, they cannot be personal, but if a metric is broken down by a unique user identifier or a rare attribute, it can become linkable and therefore privacy relevant. Another risk is that tracing is often widely accessible to engineering teams, and if traces contain personal information, that access becomes a privacy exposure channel. A privacy-aware approach limits trace payload capture, applies redaction, and restricts access to traces that include sensitive context. When observability is engineered thoughtfully, teams keep the operational benefits without turning tracing into a hidden mirror of user activity. Logging for compliance and auditing can support privacy by proving that controls are operating as intended, but it can also become a trap if the program collects excessive detail. Audit logging focuses on high-value actions like authentication events, permission changes, administrative access, and data exports, because these actions directly affect privacy risk. The goal is to produce an evidence trail that supports accountability and incident investigation without recording unnecessary content. Beginners should recognize that audit logs are not the same as debug logs, because audit logs should be more stable, more protected, and more closely tied to governance requirements. Another important idea is that audit logs should be protected against tampering, because if an attacker can erase or alter audit trails, accountability disappears and privacy incidents become harder to investigate. This is why audit logging often includes strict access controls and careful handling of retention, because these logs are both sensitive and important. Audit logs also support transparency, because they can help an organization explain what happened during an incident and how it was contained. When audit logging is designed around meaningful actions, it strengthens privacy by making misuse harder to hide and easier to correct. When it is designed as a catch-all, it creates noise and risk without improving accountability. There is also a human side to monitoring and logging that matters for privacy, because people interpret and share observability data during normal work. Developers might paste logs into tickets to get help, analysts might export data into spreadsheets to analyze trends, and support teams might capture screenshots for troubleshooting. Each of these actions can create uncontrolled copies of personal information if the observability system contains sensitive data. A privacy-aware program reduces this risk by building safe workflows, such as providing sanitized views, limiting export capabilities, and training teams to treat log data as sensitive by default. Beginners should understand that policy alone is not enough, because under pressure people will use the fastest path, so the system should make the safe path the easiest path. This might mean providing tools that automatically redact sensitive fields when copying logs, or creating incident reports that reference secure links rather than embedding raw data. It also means establishing clear boundaries around who can access production logs and when, because easy access can lead to casual browsing that violates privacy intent even without malicious intent. When the program accounts for human behavior, monitoring becomes safer and more consistent. The goal is to support real work without normalizing unnecessary exposure. Monitoring should also be connected to data lifecycle management, because privacy programs must know where personal information exists, and observability systems are often overlooked repositories. When organizations build inventories of data assets, logs and monitoring data should be included as first-class datasets with owners, classification, and retention rules. This matters because deletion commitments can be undermined if identifiers persist in logs long after primary records are deleted, allowing continued linkage and tracking. Beginners should recognize that even if logs do not contain full records, persistent identifiers can still allow association of events with an individual, which may conflict with deletion expectations or purpose limitations. A privacy-aware design chooses identifiers carefully, prefers ephemeral correlation IDs when possible, and ensures that log retention aligns with legitimate security and operational needs. It also ensures that backups and archives of observability data follow the same retention discipline, because observability tools often create long-lived archives for cost optimization. When lifecycle thinking is applied, the monitoring system becomes part of the controlled ecosystem rather than an unmanaged attic. That control is what keeps privacy intent from fading as systems grow and as observability becomes more powerful. Lifecycle alignment turns monitoring into a reliable support function rather than a hidden risk source. As we conclude, the core lesson is that monitoring and logging can protect privacy by improving detection, accountability, and incident response, but they can also create new exposure if they become an uncontrolled collection of personal information. A privacy-aware approach begins by recognizing observability data as real data, then applying purpose-driven collection so only necessary fields and context are captured. Minimization practices like redaction and avoidance of sensitive content prevent the most damaging accidental exposures, while strong access control ensures that centralized logs are not broadly browsed or exported. Retention policies tied to purpose, enforced automatically, reduce long-term exposure and support defensible lifecycle management, especially when alerts and downstream tickets are treated as additional disclosure channels. Centralized tools like SIEM can strengthen detection, but require strict governance, so correlation does not become surveillance, and so access remains narrow and audited. Modern observability practices like tracing and metrics must be engineered to avoid persistent identifiers and excessive payload capture that would quietly expand privacy risk. When monitoring is designed with these boundaries, it becomes a privacy ally that helps contain harm quickly, prove control effectiveness, and maintain trust without creating a new dataset that is more dangerous than the systems it was meant to protect.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.